Now, the idea here is that, I've been pulling together a couple slides. I was asked to join this tech conference sort of last minute. I didn't have a lot of time to pull together something formal, but I thought it'd be kind of interesting to use it as a thought exercise for a bigger presentation I have to do in a few months around geospatial storytelling. So, I like to ground discussions in perception and in what is foundational in how we tell stories. And this is one of the most discussed pieces of art because of the complexity. And we're looking at a nice wide rectangle. When you look at rectangles, there's no symmetry here in this photograph, correct? There's a tension. The tension is, who are these people? Who are they to each other? Why are they looking at us? Where are we in this picture? And this is called Las Meninas. And I love it. I use it a lot when I'm getting people kind of primed to start looking at visualization, because what we see here is kind of interesting. There's a painter all the way on the left looking towards us, almost like we are the ones being depicted in his rather large scale painting. You can see the back of the frame. And then there's a mirror with a reflection of, is that us? It's supposed to be the king and queen, I guess, of Spain, but it's just very interesting where the gaze is of the people in the photograph. And we spend more time on this in an actual workshop setting, but it's very foundational to introducing tension and question into visualizations. And what's more visual than a map? Because if I just crop this, I know it's a little fuzzy, and I just made it a portrait, there's no tension, there's nothing here. So we have to remind ourselves that it's important to zoom out and ask big questions. And this is just who I am. You guys probably all know this already. But my next two places bigger places that I'm going to be appearing is at the Boston Heinz Convention Center at the Open Data Science, where it's all data scientists. And I'll be bringing geospatial to the big stage there. And that's going to be a lot of fun. And then SciPy, I'm the diversity chairman, and I'll be there all week in Austin, doing some grading, some tutorials, and things like that. Now, what I really like about this Financial Times article is, I'm just going to scroll through it because it really is paramount to what story is and how I got the idea of how to build a story. And you can too. Look in the news, look in journals that you subscribe to, because it's very interesting. We all heard about the devastation in the earthquake, and you can see the buildings collapsing. And there's a huge geospatial component to how we can tell a story. And it's very interesting how they found a residence called the Renaissance, where there was the devastation was uniquely observed, not uniquely observed, but observed in an interesting way. And you can see here in yellow is that building, and then you can see after the earthquake that it crumbled to the ground. And the story here is, well, how did they find out about it? How do they know about these buildings? How do we decide if there's damage or potential damage? And this is all done by satellite. Satellite, to simplify it, can look at something that's changed since the last time it's viewed. So we use that a lot in disasters, and you can see these buildings and these polygons that are loaded. And the reason I'm telling you all this is because we're going to be looking at how we could do this with open source tools. So, like they say here, you can't do it just from the sky, but you can at least see where it looks like most of the devastation took place. Because if you look over where that yellow rectangle is, where the residence is, it's in the middle of a lot of buildings that probably weren't damaged or destroyed. So that begs the question, like, why was this place uniquely impacted? And here's its proximity to the fault line. And I don't want to land here, but what they noticed is that the way the building fell was uncharacteristic of just being impacted by an earthquake. And that's kind of where the story developed, is finding out that this was not the characteristic way that a building would normally be impacted by an earthquake, had them dig a little deeper to figure out what was going on. And what they found out is that, during the campaign, well, there was campaign promises made by Erdogan and all of that, and builders were allowed to not have to do the safety inspections or adhere to any of the building codes. And so right here they had like a construction piece, and he was securing votes, but what he ended up doing is building a lot of unsafe buildings. And that could be part of the question we might want to ask: why in that area where a lot of buildings were not impacted, why was that big, very, very lucrative commercial building impacted so strongly? So now, now that I've introduced you to the point and the why, let's look at some of the fundamentals of geospatial analytics. And I'm going to spend some time talking about like a GeoID, like what this is, why we have to look at spatial statistics differently. And as we know, it's because of the shape of the Earth. It's an oblate spheroid. It's not a perfect circle. And then on top of all that, the measurements that we do with water surfaces, where are we making the measurement? And, we need to understand longitude and latitude and why that impacts location on the surface of the Earth. And projections are really important to introduce to people that don't really understand this, because, depending on what area of the world you're looking at, you're going to want to focus on different types of projections. You don't obviously want to be in a part of the world or show data on a projection where that area is distorted. And they just have a couple of these projections that are famous for one thing over another, retaining the landmass shape, or being most used when looking at world data. And Tobler, geography, we have these principles of things being related to everything else, but near things being more related, and that's Tobler's first law. And it really does have a statistical theory underneath it. And this is from it was a presentation I saw a while ago, Spatial Predictions and Laws of Geography. And what's really interesting about it is there's the mathematics underneath it. We have our layers, the covariance in statistics, and then there's a target variable. And this is some of the data behind it. And then we have our second law, which is the phenomenon external to a geographic area of interest affects what goes on inside. And that's kind of where I land in terms of a lot of the work I do on social justice. Now, finding the data is also very important, and I do a lot of emergency management service stalking when I'm looking for some topics, because it's really a good use of not only of the geographic tools, but also some of the social political tools in different regions. And as you can see here, the latest Copernicus, we have storms in Mozambique, Italy, Madagascar, and we have the earthquakes. And the data can be downloaded. There's an RSS feed that you see right here, but now you can directly download any of this data and use it in your GIS platform. So here I selected Antakya, this area here, and I can download the vector package or just the static map. There's lots of things available once you can come to these websites. And it's always important to understand the data you're looking at, right? I'm just introducing this to you by ways of sharing this upstream from the actual presentation, but I still think it's really useful to understand the different types of data. You have your metadata in light blue. You really have to understand what these IDs are, because a lot of times, I work in QGIS, and if I pull the categories in, I'm not going to inherently know what the sensor GSD might be, or area ID, or what type of variable is it going to be easy for me to compare between area to area to area. So, reviewing and understanding these had me realize that I wanted to look at built up at this time, because the data that I picked, I wanted to look at the buildings. But there's a lot of other things to look at, like area of interest in the A1 area gave me my boundary and the polygon that I could loop around, so when I zoom out, I don't lose sight of where a location is that I'm looking at. You could also look at transportation, because obviously roads are going to be impacted. You can also look at natural land use, how the land use is changing, at post catastrophe, and the hydrography. So there's a lot you can look at once you look at the data models and figure out what your data is called and where it might be in the data sets. And we're going to come back to all this, but I just pulled out an area here to look at, and you can see all the info. It's all layered on here. You're going to need a more impactful data question to make this make sense, but you can kind of see some of the structures. You can see structures that might have been impacted. Some of their legend stuff, the roads are, everything's all layered on there. It's just to kind of give you an idea of what's available. And you can go into the portal there and just do this within their tool as well, without, pulling it in and asking bigger questions. And this is just where I got most of this. NASA, a lot of times if you go to Esri and you see great data, they got it from somewhere, right? So you can just kind of figure out where it came from. And that's where some of these items, and this is just very specific to the Turkey earthquakes that I was interested in. You can see vast amounts of vector data and raster data available for query. And this was on the ArcGIS. And what's really interesting here is, if you understand the web map service, here's your ticket. You just need to know about this link, and we're going to bring it into QGIS and load it up in like 3 seconds. But you also get some information about what we're looking at. There's different remote sensing labs, different passes on different days. And, Kaggle does a lot. So Kaggle had the data up pretty quickly as well. So it was also an interesting thing. I code in Python, so I really liked being able to access a notebook and look around and then see what I could recreate, what questions I could ask. And so that leads us into the tools. And, just a quick caveat, the books that I write, like the 2 books I wrote so far that are done and published, they're not the complete treatise. It's not everything there is to know about Python. It's not everything about geospatial. It's not everything about SQL. It's enough to get you started. So you can use the tool in whatever way you want to use the tool. I mean, a lot of people are saying, wow, I wanted to know more about this, that. Well, yeah, that's great. But now you have that and you can build on it. So what I wanted to show you here is these books are built to kind of get you up and running quickly, not to make you an expert in Python or geospatial or SQL. And I think that's important to say too, because, now you can go experiment because you have foundational knowledge and you understand the syntax and the lexicon, and you also know where the resources are located and the best ways to build out some of these queries. I use Colab Pro a lot as a notebook. You could also run things in your terminal, obviously, using Jupyter Lab, Jupyter Notebook. I use a lot of the stuff in the terminal, but for the purposes of this talk, I was just showing a simple Colab notebook and why they're great. They're in the cloud. What I like about it specifically is that I can pull in files off of Google Drive and have them all sitting right here. So when I have to put information into my code, I can just get the link right live to what's in here and run the code. So this is just a little snapshot. This isn't a live notebook. But, the data was great. I mean, you had to know how to adjust it a little bit to your query. But what was really interesting is the way the maps worked is they're all tiles, a tile service. They're all in there. And you could run a quick histogram and see which areas had the most likelihood of damage. Like Gobasi, Gaziantep. I'm not, it's just very interesting. And we're going to dig a little deeper into that vector data and take a look ourselves. But, there's a Pythonic role in it as well, and that's definitely an open source tool. I use a lot of SQL. I like using databases, especially when I'm working in groups. It's easy to share to create schema. So this is just a really brief introduction, but you have to download the Postgres app first onto your computer. This is important to know that your host is the local host. Your port is always 5432. If you already have a port open, you're going to have to change this to 5433 or something else, but this is usually always the default. And this is just your username and whatever database you created. So once you create that, now we can have open source administration in a development platform. And pgadmin is what I choose to use. And what I love about it a lot is it's feature rich, as it says here, but it's also very intuitive. And I'm not stepping people through specifically here, but a couple things I wanted to show that I think are really, really interesting are how you develop your hierarchy, all of these things. You can create schemas. You could have a public schema, and then you can name your schema. So I usually do it for projects. So if I'm like Boston for the presentation there, I'll have a Boston schema where I'll have all that stuff organized in my tables and all my data organized in there. And you'll notice right here, you have to add an extension. You always have to add your Postgres extension. There's a raster extension to be able to use some of the spatial components. And what I'm showing you here is just really quickly, if you're on an Apple computer like I am, you have to load first you got to create your database is over here, and then you load your data in QGIS, and I'll be showing that. But once it's loaded in QGIS and you refresh it, it all shows up right here in pgadmin 4. And what's really interesting about that is once I hit my tables and I hit refresh, I had all of my data loaded. And I just ran a really fast query layer in SQL, and I now have 721 functions. I probably use 7, but there's a lot of power behind here. And all this is here was just pulling in the facility data. And if you just hit on any one of these little polygons, it's going to tell you it was a photo interpretation, so it wasn't live on the ground. It was probably done by satellite. They didn't see any damage. So you're just getting a lot of information. And, speaking of those functions, I just did like a snapshot of the spatial functions. There's much, much more, but I just thought this was really interesting just to see the power and capability. And then we get to QGIS, downloading QGIS, and then just creating your connection. And you just do that. You create the connection from your browser window. I'll add that when I do the talk, but if you go into QGIS, I'll point it out when we get to a slide that shows it. But this is just how you create the connection, because you'll have the SQL, the connection will be there. The Postgres SQL will be there. You just have to set it up, and you'll have to name it. It could be anything you want to name it. That local host I was telling you about, unless you have an IP address, the default port, the name of the database that you set up already. You set it up already in Postgres. And, everything else you could customize. You could test the connection, which is going to tell you whether you have it set up right. I suggest authenticating if you just get in the habit of authenticating so that your data is protected. And then it lives in your database manager. So now it's in QGIS, in the database manager. This is how we add the data now, the data I was talking about. So you just go to your public, your Turkey. I was just using Turkey here. Earthquake, and my server was Postgres. So this is all ready to go. I import the data into here, and then now I can use it. And here I am importing a vector. So you import things one at a time. And I included this because your schema could be public. You could change it. You could import only selected features. Some of these are big, so maybe you're only interested in looking at one feature. It'll let you filter it down. I always pick a primary key. I always pick geom. Uh, some of these things QGIS does natively, but I like to just kind of see it and do it because this reminds me if I want this to be different, I change it here. I like to convert field names to lowercase because I'm bad at that. When I'm naming, you'll see in a minute. Like it's good practice. And I create my spatial index here as well. And then everything loads up. So this is that browser window I was telling you about. When you set up your QGIS, the panels that I pick are browser, layers, processing toolbox, and layer styling. And then other things you can add, depending on the projects that you're working on. But I always have them hanging as panels and you can adjust the size of them. But here's where this is where before I added this database, this was just the logo. And then I customized it. Now it's got data in it. And when you load these in, as you know, you can't just pull a shapefile over. If you're in QGIS, you can. But otherwise, you need to have all these other co-folders come in with it. So if you're working in Colab, you're going to need to pull all of them. But if you just slide the shapefile over, it all ends up in the right place. So here's what it looks like just in the browser before you've done anything, before you've created a database over, or before you start using pgadmin. It's just this. Once you customize it and create that first, and then connect it with QGIS, now you have all your data in one place. So, a quick introduction to plugins. There's so many plugins that I use, and I could spend days just explaining to you the projects that I use those for, but Quick OSM is a good one because you can just add data right to your maps. Now, a lot of the data that I added is from GeoFabrique, which I'm going to make a note to add a slide for that because it's not here. But that's where I get a lot of my data, my parcel data. And as you can see here, we have this whole region here that didn't really have a lot of damage because the notation here, as you can see, no visible damage. There's a couple here that were damaged and maybe a few that were destroyed. But this is just how you pull the data into QGIS. And here are the three different regions I was looking at here. You have Hatay, then you have, I think there's another one here, just looking at the different areas and the different ways the data was captured. This right here, this data layer came from GeoFabrique. So I'm going to be adding that in, which is it's very, very current data. Like every day they update it. So it's a very good resource for pulling in vector data from all over the world. And I pulled a section of the book just to kind of see spatial and non-spatial functions because there is a little bit of an interest in SQL in the group that I'm going to be talking to. So I just wanted to simplify that query-based syntax because in a quick conversation, you're not going to get everything you need, obviously. It's sort of like an introduction to the book and where you could start wrapping your mind around what SQL is actually doing. So if we simplify it, you're really just picking columns from a table, right? Because the database is storing all these information as tables from a data source. So the data source is going to be like how you've named that table, whatever that data is, and then where some condition. It's going to be a where clause of some type. And you'll see that as I show you a couple. And these are non-spatial, but they kind of explain that you can get columns from tables, you can get data from tables, you can get numeric, you can get, select distinct, you can get a lot out of just tables before you even start thinking spatially. And one of the spatial ones is just buffer. And what this is in the protected lands in Brazil, I wanted to create a buffer region and see what was within 5 meters, just as a tool, just to teach how you can ask geospatial questions of these big data sets and these vector layers. But you can see we're taking this column, which is an ID, a unique identifier, and we're going to buffer the geometry around it from this is the schema, which was chapter 5, and the table is boundary protected area, and where I want to know where the protection, so this is a data value in that column, where it's the reserva, where it's in the reserve, the protected reserve. And the good thing about SQL is when you start using it, it becomes very conversational. So right here, I just decided I want to pull in built up, which is these buildings in this area in Turkey, and I want to see where the damage grade, so the column heading is damage grade, and in the column is the option destroyed. So I want to see where it's saying from the satellite data that the buildings were destroyed. So I'm loading it as a new layer. This is all in Database Manager. You just click this little guy, the little wrench, and all this loads. Well, this loads, then you put your code in. Wouldn't that be nice? This isn't ChatGPT happening here. And then you have your unique values. You have to be careful here because sometimes you don't have a unique value and you have to create one. That's a whole other conversation. Easy to do, but it takes a few steps. What is your geometry column called? Usually it's geom. Depends on where you get your data. Just pay attention to some of these things. You can name your layer. And when you bring it in, you have to update the layer to see the changes that you asked for. And once you do, we have 68 columns. So we have 68 rows fetched. And here they are. So now the data is now just showing us the vectors. Remember, it was loaded with vectors. Now it's just showing us the destroyed ones, which is the black that you see. Now, when I look at the data, remember we said there were 68, and I'm looking through this is why it's really good, it loads up the table. And you see we have two different ID things. We have ID, and we have this ID. This is when you update the query. But if you notice, what happens here? These are unknown. We don't know where these are. So maybe we don't want these in our data set. So how can we get rid of them? Well, in SQL, it's pretty easy. Because now I can say, because now I know 994 is the known and 1 is the unknown. So now I can just ask it to sort it all and just return those. And it gives me 44 rows instead of the original 68. This is what we had originally, and this is what we have now. I just changed the pattern, the grids to a crosshatch so you can see. So now we've cleaned up the data a little bit. And here's more of those NASA products that I was telling you about. I wanted to remind you of where it came from because we were looking at that web map service endpoint down here. And you have a nice little description of how to use it. So when you're looking at the color standard version and color vision deficiency, which is coded as CVD, you'll see that when you're looking at it in my QGIS. But they're just telling you the color. From yellow to red, it means there's more surface change, right? There's a drop in that radar reflection coherence. And the same thing if you're using the CVD version goes from light blue to dark blue. So depending on what satellite you're looking at, what date you're looking at, some of these hues are a little different. And so what you do here, you go to your browser, which I just blew it up over here, but it's over here. Here's your web map service. And I blew it up so you could see it. And it'll open. And you take that link that I showed you that was on the ArcGIS page. You can just put it right in here. I don't authenticate or anything. I mean, you could do all this stuff. You just run it, and it loads into it'll load right into your browser. So it's right here. And you can just click it and add it to your screen. So here's those areas that were hit. So the darker areas are where the more devastation is. And if you could look right down here, this is the region that I was interested in. So you can see how it's a little isolated from some of the main damage, but it's scattered all over. This is just hitting Turkey and showing you. I even have the tectonic plates that I loaded into here, which you can see the red gets a little buried underneath the thing, but you can see the proximity to these plates, to these darker areas. There's just a lot you can pull into the frame. And I'm just kind of blowing it up a little bit so you can see a little better. And this is the area I just zoomed in on, and you can see devastation within there as well. And I'm ending it really on, this is a blow up. So we have these vectors, and there's a vector missing here. So what it looks like potentially is that there was a building that's no longer there. So this is just showing you how you can use geospatial and open source tools. This is where I would ask for questions, and here's where I end the conversation. I hope you found some of this useful, and now I'm just going to spend some time building out a lot of those thoughts and processes for my talk tomorrow.